All right, we're going to talk about areas of circles and sectors. Some vocabulary, just quick reminder, area of a circle. Area is equal to pi times the radius squared. Another formula is population density, and just understanding population density is how many people will live within a given area. So the formula then would be the number of people in that area divided by the area of land. Now that area of land could be, like it could say how many people live within a radius of a city, and then the area of land would be a circle. How many people live within a city, and they just give you the square miles of the city. Or how many people live in a certain region where they define what the region shape is. Okay. And then area of a sector and sector of a circle. So first, a sector of a circle, if you kind of think of like a pizza, we'll call it circle P. Okay. And you think of arc AB on circle P. That arc that's intercepted has a sector attached to it. So the sector is like a slice of pizza. So the area of a sector there. Okay. And so the area of a sector, if this is our radius, we would first want to find out how many degrees there are within that sector. So let's say this was, say, I don't know, we'll just use 60, a 60-degree angle. You would be taking the measure of that arc, the measure of arc AB, which in this case would be 60 degrees, and dividing that by 360. And the reason you do that is because that tells you what portion of the circle you're dealing with. So 60 out of 3/60 is 1/6 of your circle. And that's going to be equal to, or I guess, well, yeah, I'll go ahead and do it that way, is going to be equal to the portion, the ratio, the area, the area of sector APB, okay, so A to P to B, over pi r squared. So that would be equal to the area of this sector over the entire area of the circle. So that would mean you'd want 1/6, in this case, I guess, 1/6 would be equal to the area of sector APB over 360 degrees. Okay, and so, or excuse me, over pi r squared. All right, and in this case, the radius, if we had a certain value for the radius, say if the radius was 7, it would be over 49 pi. Okay, and then you can cross multiply. But really, I'm going to erase this part. Really, if we just keep it kind of generalized, the formula from here, if we just want the area of the sector, the area of the sector, to get this pi r squared over to the other side, you can multiply by it. So you could have pi r squared times the measure of arc AB over, or the measure of your arc, over 360 if we're really trying to make it generalized. That is the area of a sector. That's the formula for the area of your sector. Okay? All right, so using that formula, we can actually go ahead and try to solve some problems here. So let's practice finding the area first. Okay, just a quick review problem here. Find the area of a circle with radius of 1.5. So if r equals 1.5 and area equals pi r squared, we're just substituting 1.5 in for r, and that gives us 2.25 pi. Okay, and that's in square inches. Now that's your answer in terms of pi. So if it ever says give your answer in terms of pi, that is it. That's the exact answer. Now if it wants you to round it, say like round it to the nearest hundredth, you'd actually have to calculate 2.25 times pi, which would give you 7.07 square inches. Okay, it just depends what they're asking for. If they don't ask, then you're usually fine just leaving it in terms of pi. Okay. All right, find the diameter, switch colors here, of a circle with area of 126.5. Well, once again, if I know the area of a circle, that's equal to pi r squared. Okay. And substituting the pieces in, I know the area is 126.5. That's equal to the pi r squared. Now they're not asking for the radius, which is what the only variable we could solve for here. They're asking for the diameter. But remember, the diameter, d, equals 2 times the radius. So if I can find r, then I can substitute that in and double it and find the diameter. So let's go ahead and solve this for r here. Okay. So to get r by itself, I'm going to divide by pi. So 126.5 divided by pi equals r squared. Notice I did not do the math there because that's going to give me a decimal. It doesn't end there. So no rounding yet. And then get rid of that squared by taking the square root. 126.5 divided by pi. And that's actually what you put in your calculator. If they want the exact answer, well, that's the exact answer for the radius. And so the exact answer for the diameter, well, the diameter would equal 2 times r, or 2 of these roots. Now that's the exact answer. Now you could go ahead and put that into your calculator and solve it. So the diameter is 12.7 centimeters. That's your rounded answer. All right. Well, hey, we have a population density problem of Lake Stevens here. The population of Lake Stevens is 32,000. The area of Lake Stevens is about 9 square miles. Find the population density. Remember, population density is equal to the number of people, or the population, over the area. Okay, so in this case, number of people, 32,000, divided by the area of 9. 32,000 divided by 9. Let's go to the nearest person here. That's going to give me approximately 3,556. I think it's 55.5 or something. People. And that's per square mile. Holy moly. That's a lot of people in a square mile. All right. Let's find some areas of sectors. Now remember the formula for area sector? Okay, we just kind of came up with it at the beginning here, but the area of the sector, whoops, sorry about that. So the sector area is equal to the measure of your arc over 360 times pi r squared. Okay, so find the areas of the sectors formed by CAB. Well, that would mean we have this sector right here, but we also have that unshaded big piece right here. So let's go ahead and find the area of the smaller sector, okay, and we'll call it CAB, and we can call the other one the one formed by arc CGB. It's also CAB, but we have that G in there, okay? So we're going to find our smaller area first. So I'll just label it as smaller here for now. Okay, So the area is equal to the measure of arc CB over 360 times the area of the circle, or pi r squared. So that's going to be 117, the measure of arc CB, is equal to the central angle, over 360 times pi, and then r is 5 squared. That's going to give me 117 over 360 times 25 pi. Which, if you simplify that, you multiply this out, you actually get, without multiplying out the pi, you get 117 divided by 360 times 25, gives you 8.125 pi, which is your exact answer. That'd be in square centimeters. Okay, so that's the exact answer there. Or if you rounded it, you would have 25, approximately 25.5 if we go to the nearest tenth, in square centimeters. All right, notice 8.125 times about 3 is about 25. Okay, if we switch it up and actually find the area of the bigger, okay, the larger area, we're going to have same idea, area is equal to, but the measure of arc this time, CGB over 360. Don't know why my stuff isn't lining up there. There we go. Times pi r squared. Okay, so the only thing that really changes is the arc measure. The arc measure now, rather than being 117, okay, this arc right here is 360 minus 117, okay, which gives me 243. That's 243 over 360 times, well, pi r squared we already know is pi times 5 squared, or 25 pi. We do the math there. 243 over 360 times 25 is 16.875 pi. That's the exact, and that would be in square centimeters, which is about, if we were to round it, 53.0 square centimeters. Now the other way you could have done it is you, after you found the area of the smaller, you could have found the area of the bigger, the whole circle, and subtracted it. And that would have given you the area of the remaining. Okay? All right, let's try to look at it a different way. Let's say we actually know an arc, or arc area, or excuse me, a sector area. So we know this area, and we want to know the area of the entire circle. We still use the same formula. So the area of the sector, so sector area, is equal to the measure of your arc over 360 times the area of the circle. And if we call that our circle there. Well, the sector area is 55, and the arc is 40 over 360 degrees. And we're going to multiply that by the area of the circle. So I'm just going to call that A. And notice I didn't use pi r squared because I don't want R, and I'm not going to plug in an R. I just want to find A. I want to find the area of the circle. Okay. Well, when I do the math here, I can reduce this. This can be actually 55 equals 43/60. This is actually 1 over 9. So 1 over 9 times A. Well, get rid of this fraction by multiplying by its reciprocal. So that would mean 55 times 9, or 495. And that's equal to A. So that's the area of the circle, is 495, and it'd be square meters. All right. So this should be 1/9 of that. If you divided that by 9, you'd get it again. Let's try one more thing. We kind of have this composite figure. It's two shapes put together. The dimensions of a high school basketball key. So the key is like the rectangle part. And the semicircle at the top of the key, the half circle, are shown below in the diagram. Your high school will be painting the key and the semicircle. So to the nearest foot, what is the area of the region that the school would need to paint? Well, you can approach it in a couple different ways. I'm just going to approach it as finding the area of each. So if I find the area of the key, which is just a rectangle, right? It's just equal to length times width. And I can find the area of the semicircle, which really is equal to, whoa, sorry about that, A equals pi r squared. That would give me the whole circle, so I just want half of that. I want half the circle because it's cut in half. That'd be A is equal to 1/2 of, well, the radius. Well, if this is 12, then the radius is half of the diameter, which would be 6. 1/2, 6 squared. So we get 6 squared is 36, so we get half of pi times 36, which is half of 36 is 18 pi. Okay. The area of the key, well, that's length times width. So over here, we'd have A equals 12 times 19, or 19 times 12. So A here is 228. Well, the total area, the exact value, would be this plus this, right? It'd be 228 plus 18 pi. Now, you can't put those two things together because this is counting ones, 1, 2, 3, 4, 5, all the way to 228. This is counting pi's, 1 pi, 2 pi, 3 pi, all the way to 18. Okay? So this is actually the exact answer, and that would be in square feet. The rounded answer, well, 228 plus 18 times pi, that's 285 square feet. All right, and that's what they asked for, by the way, was to the nearest foot. So this would be the answer you want. This right here, they don't want that. Okay? All right. Well, I hope that helps. Good lucky.